Hi guys, welcome to another physics video. In this case, well, this is the problem number 2 about the vector addition using the component methods. Now, we're gonna do exactly the same. We're gonna find the resultant force and the resultant angle. But there is something different about this. If you see, I got the force number 1 and the force number 2, but I don't have the total angle. I have this little angle over here. It will be the quadrant angle, and this is also the quadrant angle. So we're going to do exactly the same, and we're going to find out the total angle of the force number 1 and the force number 2. And remember, we're going to start by this using doing this problem using the chart that we saw the previous video. So we're gonna start with force. Okay, so remember that I'm going to fill this chart with the information. So force number 1 is just the magnitude is 10 newtons, and force number 2 equals 50 newtons. Okay, then the angle, but remember that I need the total angle. So the total angle of the force 1 and the total angle of the force 2. Okay, so the total angle of the force 1, if you see, I got 35 degrees here, but if you see, the total angle is measured from 0 degrees, so this whole way is 180. So 180 plus 35 degrees, it will be the total angle of the force number 1. So let's find it in the calculator. So it will be 180 plus 35 equals 215. So the total angle right here will be 215 degrees. And the total angle of the force number 2, if you see, the whole circle is 360 degrees, but this one is less than 40. So that will be 360 minus 40, and I will have the total angle that it will be 320 degrees. 320 degrees. So now we can perform all the operations as the previous video. Exactly the same, guys, exactly the same. So the next column will be Fx. The x component of the force equals the magnitude of the force times the cosine of the angle. Okay, so let's find it. It will be the x component of the force 1 equals the magnitude times the cosine of 215. And right here will be the x component of the force 2. It will be the magnitude, that is 15, times the cosine of 320 degrees. Okay, and this is the column. So we're going to find the sum of the x components of the force. The sum. In this case, it will be, okay, so let's open the calculator over here. So I'm gonna add this plus this, so it will be 10 times the cosine of 215 plus 15 times the cosine of 320 equals, okay, so this is the sum of this x component of the force 1 and the x component of the force 2. So I'm gonna save this into the memory A. Shift STO A. Okay, now I got this value saved in the memory A, and I'm just going to write here the number with 2 decimals, 3.29 newtons, and I'm gonna write the sign. The sign is positive. Okay, and this is saved in memory A. Okay, so let's continue with the problem. Next column, oops. The next column will be the y component of the force. That is the magnitude of the force times the sine of the angle. Okay, so let's continue. Oops. So the y component of the force 1 equals the magnitude 10 times the sine of 215. And here the y component of the force 2 equals 15 times the sine of 320. Okay, let's get to calculator. Let's perform the operation. Is 10 times the sine of 215 plus 15 times the sine of 320 and equals. Okay, I'm gonna save this value in the memory B, Shift STOP. Now it's safe, and I'm gonna write the answer. The sum of forces in Y equals minus 15.37 newtons, and I'm gonna write that the sign is negative. Okay, so I'm gonna save this value in the memory B. Okay, I already got it in B. Now next, remember that the next thing that I need to do is to locate the resultant force. And how am I gonna do that? Well, I need to see the sign of X and Y. So first I'm gonna draw the Cartesian plane. Draw the Cartesian plane. So I'm gonna ask in which quadrant I have X positive and Y negative. So that will be in the 4th quadrant. So I got the sum of fx is over here, and the sum of fy goes downwards because it's negative. So the sum of fy, and the resultant force will be in the middle of these two. It will be something like this. This is the resultant force. Okay, so I'm gonna draw the little triangle that is formed using the vectors and the sides. So this is the resultant force over here, and this is fx, and this is fy. Let's resultant force, the sum of fx, the sum of fy. Remember that in order to find the magnitude of the resultant force, it will be with Pythagoras. It will be the square root of the sum of fx square plus the sum of fy square. Okay, let's do it in the calculator. So it will be the square root of the value that I got in A, alpha A square, plus the value that I got in B, alpha B square. Okay, and that is the resultant force. One thing to keep in mind is that the resultant force is always positive. So I'm going to write the resultant force, and it's just the magnitude. It's not the vector, it's the magnitude. 15.7275 newtons. Okay, now let's find the angle. And the angle that I'm gonna find is this little angle over here, the quadrant angle. And I'm gonna call it the angle of the quadrant 4 because it's in the 4th quadrant. Angle of the 4th quadrant. Okay, so remember the formula that I'm going to use is the angle of the 4th quadrant equals tangent inverse of the sum of fy over the sum of fx. Okay, so that's the formula that I'm going to use. Open the calculator. It will be shift tangent fraction. The value that I got in b is alpha b over the value that I got in a, alpha a. Close parenthesis equals. And remember that I told you that, well, that angle, I'm gonna write it positive. Okay, so the quadrant angle equals 77.89, just two decimals, degrees. And this angle is this one, but I don't want that one. I want the total angle. That total angle, that's the resultant angle. So I'm gonna do it exactly like I did it here. I'm gonna subtract 360 minus 40. So it will be 360 minus the quadrant angle. But in this case, in the calculator, I got it negative. So the only thing that I'm going to do, I'm gonna add 360, and that will be the resultant angle. And the resultant angle, I'm gonna write it like this. The resultant for is this one at, now the direction, 282.1088 degrees. And that's the answer of this problem number 2. And remember, it's exactly the same as the previous one. The only different thing is it was this, that I gave you the quadrant angles. I didn't give you the total angle that is measured from 0 degrees. So, okay guys, I guess this is enough for the problems of vector addition. In the next problems, we're going to see problems talking about motion in one dimension. Okay, see you guys.